Hello and welcome to CNC Beginner's Guide. My name is Stephen Thompson, and today we're going to be going over Project 2 CAM Part 1. And in this video we're going to be going over creating the setup for Part 2 CAM. Now the setup is where you set all of your initial conditions of your machining situation, including model position within the stock, location, orientation of work coordinate systems, and a couple other things. And this is it's really important to get your setup just right, so that your toolpaths are accurate. So there's a lot of details. Let's get going. Okay, so here we have Project 2, and in the previous video we went over how to do the CAD for Project 2, so how to draw this 3D model in Autodesk Fusion from a 2D drawing. And now we are going to create the setup so that we can create toolpaths to program a CNC machine to make this part. So the first thing we're going to do is we're going to switch from the design environment to the manufacture environment. Okay, and when we're in here, first thing I'm going to do is I'm going to check my units. So depends on how you have your Fusion set up. You may be set up in millimeters or inches. I'm going to change my units by clicking the little Change Active Units button here next to my units. I'm going to change it to inch and click OK. And the reason I'm doing it in inch is because I want to be working whatever units my tooling is in, and that's just my kind of personal preference. It's also important to on some machines you have to make sure that you're generating G code for that machine that is in the units that machine is expecting. Some machines can tell the difference, but some machines can't. So you have to know your machine and you have to know what it's expecting. There is an option at the very end when we're making the G code to change the units that it's gonna, the units of the G code. So you can do that there. You can actually work in inches in this environment here, and then you can export your G code in millimeters if that's how your machine works. The important thing is just to know that there's a difference and to know that you have to specify at some point. Okay, so we are in units, we are in inches. Let's go ahead and make our first setup. So I'm going to go to Setup and New Setup. Okay, so we have here the Setup dialog box that pops up, and in the first, in the Project 1 CAM series, for the setup, I went into a lot of detail about all these kind of different things and tools and machines and things like that. I'm not going to do that every single time. So if you want like a more kind of broad overview of the setup dialog box, go and check out Project 1. But for here, we'll just kind of make the settings. So first thing I always like to check is under this model section here. So we're in the setup tab in the setup dialog box. In the model section right here next to model, it says body. If I click on that, I can see the model that is going to be, it's the thing I want to machine. That is turned blue, and it's just one object, and that's exactly what I want. Sometimes you're working in an assembly of different objects, and you might have multiple bodies, and maybe you just want to, in this program, focus on one body, and then you would specify which body that was. But there's only one body in this file, Project 2. Okay, so that once that is set, we can start from the top here. For machine, we're not going to select a machine. You can select a machine if you want to have your part be kind of inside of a virtual machine while it's being while the toolpaths are being simulated, but it's not necessary. It can be helpful, but it's a bit more complicated, so we're going to leave that empty. Under operation type, milling. So if you're milling this on a mill or a router, a CNC router, that would be the option you choose. Now, work coordinate system. So we want the orientation to, right now, by default, it's going to match the model orientation, which you can see the model orientation based on this view cube at the top right here. See that it matches the orientation of this work coordinate system. But that's, never really going to be the case. I mean, sometimes it might kind of randomly be, but you always have to kind of adjust this. And this is quite easy. What we do here is we change orientation type to Z-axis plane and X-axis. You could choose these other ones too, but I like to do Z-axis plane, X-axis. And in it, what I do is I specify what is the z-axis. So what is up and down, right? When we're thinking about this orientation, really what determines the orientation is how the CNC machine you're going to use orients its coordinate system and the way that you want this part oriented during machining. So that kind of depends on what your vise or what your work holding looks like. And so that'll kind of, guide these choices. But the rule of thumb is that use the right hand rule, where if you put your right hand out in front of you and you point your thumb to your right and your index finger away from you and your middle finger pointed up, then your thumb points in the positive X direction, index finger points in positive Y, and middle finger points in positive Z. And this is true when you are, for most CNC machines, not all of them, most CNC machines, when you're standing at the front looking in. So if I want this part to be oriented like this, with the kind of long part of it going left, right, then I would, when it's in the CNC machine, I want it to be like this, then this is how I'm going to set it. And I'm going to make sure positive X to the right, positive Y is away from me, and positive Z is up. You could orient it like this if that's how it was in your machine. But we're going to orient it like this because that's how the vise is in our machine. It's kind of like long part of it is left to right. So for Z-axis, we can select a plane and it'll make it perpendicular to that plane. I'm going to select this plane. You could also select a line and it'll put it along that line. Now we notice that since I selected Z, it's moved on to X. It's asking me to define what X is. And X is actually pointed in the correct direction, to the right. I could also select a line, which would define explicitly where X was pointed. You can swap the direction of these arrows by clicking on the arrows themselves. But this is how we want it. Positive X to the right, positive Y away from us, positive Z up when the model is in this orientation. And that way it'll match the orientation of the coordinate system inside of the CNC machine. Okay, now stock point. This is the location of the work coordinate system. And this depends on how you're going to tell the machine where this point is. Different machines have different capabilities. Some machines you put in an edge finder and it comes in, it finds the edge of it. Some machines have a digital work probe and they can find very, very accurately the center of the model. So, depends on how you have your machine set up and what your machine's capable of. But I like to do the top center because I know that my machine that I'm going to be machining this on can find that top center easily using a probing kind of sequence. Okay, we've done that. Model fixture. This is if we were to specify the vise or the work holding, but we don't have that set up, and it's not necessary. It's helpful to make sure you don't get collisions in the simulation, but it's not totally necessary. Okay, that's all for the setup tab. Let's move on to the stock tab. Okay, for the stock, the mode, this is really, there's a lot of different things you could do. You could do, right now it's on relative size box, so it's making a box of stock around this model that's relative to the size of the model. And depending on what your situation is, you might use a different one of these. We're going to use fixed size box because we're going to cut a piece of stock to a specific size, and then we're going to use that. So for width X, our part is 2 inches wide. If I get a side view of this, I'm going to click on the view cube at the top right here to get a side view. I can see that our part is 2 inches wide. If we make our stock also exactly 2 inches wide, it's probably not going to machine all the stock away. It'll leave some edge of the original one, or if there's any error in probing, it won't be quite there. So you need a little bit of a buffer in order to make sure this thing is completely machined outside of inside of the stock material. So I'm going to say that when I cut my stock on the bandsaw or whatever, I'm going to aim for something like 2.25 inches. Gives it some more left to right distance, which is good. That number is just a placeholder because when I actually cut it, it may be different than that. And I have two options. I can either take that piece of stock and make sure that it is is exactly this amount by maybe putting it on a manual mill or something like that. Or once it's cut, I can measure the actual size. I can come back here and I can change it before I machine. The only reason I'm guessing here right now is because I haven't cut the stock yet, but I know it's going to be close to this. Okay, so looks like our we get a side view here for our Y. It's centered and there's still material on both sides, which is good. The one thing I'm going to change is, so yeah, there's two parts to this. There's the dimension of the stock in that on X, Y, and Z, and then there's the position of the model. Now, model position in X is center, which is good. It puts it right in the middle. So it's going to make sure that that buffer zone is equally kind of on both sides. And same thing with Y. That buffer is equally on both sides. So the one thing I'm going to change is Z, because right now the model is centered in Z, but I know, and this is just because I know I'm going to hold this along the bottom edge with a vise, and I'm going to need as much clearance between the cutting tools and the vise as possible so that I don't get a collision with the vise. If you have a different work holding situation or if something is slightly different, you may actually have a different choice to make at this point. You may do something different. But what usually in these kinds of cases, what I'll do is for Z, I'll say model position is offset from top. And for offset, I'm going to change it to a number that is going to be the amount of the depth of the first cut. So when it faces the top of the part, it's going to cut off this amount because that's the distance below the top of the stock that the model is positioned, and something small like 0.05 or 0.02, that works too. 0.05 is a good number. Okay, so that is it for the stock tab, stock size, and the model position side of the stock. Under post process, we have the program name and number, and this number, it depends on the type of machine that you have, and the number or the name that it can understand. Not every machine can understand like just a typed out name or alphanumeric thing. Some of them can just understand numbers or just expecting numbers. So know what your machine is expecting, or know what your machine can handle, and then you can kind of write it out here. A safe thing to do is just a 4-digit number, and I'm going to write, since this is project 2, I'm going to write 2001. And I'm going to write here under the comment, project 2, setup 1, and then my name. Okay, and that's just kind of some bookkeeping, so that when I'm actually on the CNC machine, this comment gets written into the G-code. And I can see it. I can see that, this 2001 is actually my file, because someone else may have another file that's the same name, and I don't want to mistake it at all. So, because that's the kind of thing can lead to collisions immediately, is running the wrong G-code file. So I am putting my name in there. I'll see it at the top of the G-code, just kind of a last little assurance that this is the code that I want to run when I'm on the machine. Okay, machine WCS. The work offset by default is 0, and that means it's going to map to G54 or wherever the machine stores the work coordinate system originally. But this is kind of an advanced thing. You can adjust this, but only if you have like special work offsets saved in your machine. So like maybe you probe like a certain part on your vise, and you have that vise in the CAD model here, and it means that in order to run this part, as long as the part and the model are in the correct position relative to the vise, and the vise is in the same position in the machine, then you don't actually have to probe your work. You can actually just have the machine use that specific offset that corresponds to whatever CAD model situation here matches the actual machine situation. So it's a bit more complicated, but it can be really dynamic and really useful. So for now, we're just going to do 0. You can also put 54 in there to make it G54, but we're going to leave it as 0 and go ahead and click OK. All right, let's take a look. So here is our first setup. This part is actually going to have two setups. In project one, we had a similar object, and we machined the top of it, and that was it. In this one, we're actually going to do the first part of a flip. So what we're going to do is we're going to machine the top and the first setup, and then we're going to flip it over, make a second setup, and machine the extra material off the bottom. For machining extra features on the bottom that align with the top, it's going to be another step. You have to make a third setup, and that is for a very specific reason, irregular stock, and we're going to get into that in the next project 3. But for now, this is a setup for project 1, and now we are ready to make some toolpaths. So go ahead and check out the next video for how to create all the toolpaths to machine project 2. We will see you there.